Hello, everyone. Welcome to our first speaker series in 2026. And a quick intro for myself and authors before we get to our incredible speakers for today. My name is Si Zhu, a PhD student in UMD's College of Information and coordinator for this year's Authors Speaker Series. A little information about us. Authors is the organizational teams and Ecology Research Society, a network of scholars across the DC area and dedicated to researching and learning anything and everything to do with teams and technology. It is my pleasure to introduce our speakers for today, Dr. Neal Outland, Assistant Professor of Industrial Organizational Psychology at the University of Georgia and AI Faculty Fellow of the Institute for Artificial Intelligence. His current research focus is on bridging computational and experimental methods to understand human AI team dynamics, trust calibration, and identity process in organizations. So take it away, Dr. Outland.
Thank you. Hi, everyone. Thank you for inviting me to be here. I'm really excited to be able to talk to you all, looking at this intersection of different methods that we can use in human AI teaming research. I've kept this, I'm going to keep this fairly high level as I discuss through these things, mostly so that we can get through them without getting too far into any weeds. But I do invite any questions that you have about anything that I talk about today. And one of the main points I'm going to try to make is that there's no single method. I'm not trying to support any one method. I'm really trying to show the intersection, how we can co-evolve to really help us fill some of the blind spots that we have in human AI teaming. And so we're all discussing and we're all seeing, maybe even experiencing this move from AI, from tool to teammate, especially as we're seeing things like even in just the last month, OpenClaw became a huge sensation, but we can talk about that later. But for the most part, we also recognize that the theories that we're relying on are built for tools, either when it comes to AI. But in the workplace, as we're thinking about trust and the theories that we have around trust, those are either built from the conceptualization of we're interacting with another human, or that we are interacting with some sort of utility, some tool, some computerized system. Now we have multiple scenarios that are becoming more and more realistic, more and more plausible, some even happening right now. And they help highlight some of the questions or are theorizing what might be gaps in our ability to examine human AI teaming. So taking the surgical team, for example, let's say that an AI flags a diagnostic anomaly, something like this, if it's occurring in a high fidelity environment. But we have the surgeon trust the AI's advice. The surgeon trusts that the anesthesiologist doesn't, and the nurse just has seen so many of these things happen where she's like, I've observed it fail. Well, if they have to make a collective decision, how does the team come to make that? It would be intelligence analysis. So, AI identifies something, some sort of pattern, and then additional human analysts with different experience levels, different mental models, they also have to decide together, do we escalate? How do we handle this? Who trusts the AI? Who doesn't? And how does the relationships between team members influence eventual decisions on whether or not to use AI really become paramount here? And the final one, it would be that an AI co-pilot to redesign. System. And now we can see highlighting that maybe senior engineers accept it, junior developers hesitate, or sometimes even the reverse, where we can start to see how might role and position effects influence how teams as a whole come to trust and eventually behave with AI. But inherently, these are team level questions, and most of the theory only, well, the idea that we have is most theory only answers one at a time. It only answers at the individual level. And the central kind of central to our thinking is to connect these things is, well, how can we start to evaluate and understand at what level we're theorizing in human AI teaming to make sure that we're answering all the questions that we actually need to be answering, that we'll be observing in the workplace. And we're starting with theory. Generally, this is identifying what matters, what we should be looking at. And up to this point, again, this has been an individual focus, but I'll get more into that later. And from theory, we can get into computation, which lets us formalize these ideas of theory and explore implications under thousands of different conditions to generate some of our predictions or to generate data that we might expect to see if we were able to collect it experimentally. And then we go to experimentation here, which lets us surface some of these surprises, actually explore whether our computation or any sort of model we have as a representative data generation mechanism helps us validate whether those are plausible. And one thing to know about this, even though I've presented it here linearly, this is not a linear process. And uh, in the research that we're talking about today, I'm hoping that I'm able to communicate and get your thoughts on this coevolution and where it might be directed for human AI teaming. Just each one of these sees something different, and we're hoping that this is an organizing perspective. It's not something that we have supported yet or anything like that. But let's talk about the traditions of where theory has come from in human AI teaming. And in one case, we have the AI specific view or computing and robotics specific view, and it's coming out of a computer science, human factors, HCI areas. And its core questions is about calibrating individual trust. How can we understand what factors are influencing trust or what factors go into the calculation of trust so that we can design better technology. And then the general or organizational tradition, we have this focus on relationships. We have this added emphasis of emotional trust in addition to this cognitive-based trust. And that's a key distinction. But in both cases, we still see that they're developing in parallel at the same level. So that was our original hunch. What we decided to do was to do a systematic review of the literature of theories of trust, both general trust and trust in AI. So it was a team of 9 coders, and what we eventually extracted were 50 trust frameworks across disciplines. And from there, we extracted 811 factors along 10 structural dimensions. And as we started to categorize these, we found that 33 out of the 50 were AI-focused theories, basically from the last 10 years. We had 17 general theories of trust, again, with our 811 individual factors and 10 dimensions that we coded. And so each coder were trained and then coded in pairs for each of the theoretical frameworks that we pulled. And then any disagreements were handled by consensus by looking through, our coding sheet as to like how things should be coded. And to our knowledge, as far as systematically coding these, this is the largest that's been to date, but it's still running through the review cycle. So we'll see whether or not it's the largest published one. So for each theoretical framework, we wanted to categorize it along 10 dimensions to capture, the structure of the factors included in these theories. And so the first was, what is the level that the theory specifies, or what for theories that are multi-level, what is the level of this individual factor, this individual piece of the theory? At what level is that? And so for this, we have intra-individual individual all the way up to system levels. For example, not deciding to trust the AI, but deciding to trust either the individual who created it or the organization that created it. For each factor, we also rated stability. So whether or not this was something more trait-like or something more state-like. Then we were looking at relationships to trust, whether or not these are antecedents, outcomes, whether or not it was bidirectional relationship with trust, or if it was trust, where we had methodological or operationalizations that we couldn't actually distinguish from the theory itself, from being trust versus another construct. And then for the categories, we're looking at whether or not these were cognitive factors, behavioral factors associated with them, affective factors, or contextual. And then we also went through on our agent side, whether or not this was an AI or a general trust theory, for each factor, whether or not it was referencing a human or an artificial, or could be either of the trusters. So as we're looking at these models, this factor might be perceived competence. Well, who would the truster be in that? We're looking at what the theory would outline as whether or not the perceptor, the perceiver of the competence was a human or the artificial. And then who's the target of trust? We also labeled the same, whether or not it's the human, artificial, mixed, or some higher level entity like an organization, though we didn't get any of those. And what we found after calculating all these and basically just running our relative frequencies, um, we were comparing, we did a chi-square test analysis to compare how AI-specific theories and general theories represented the various levels. The factors represented the various levels. And across the board, so for example, for individual level factors where you might be looking at something like propensity to trust, AI, these were heavily prevalent in the AI theories. However, team level factors was noticeably low. Actually, most other factors were noticeably low. Me being a team researcher, this one concerned me the most. From our read of this, AI-specific theories are highly focused, particularly for trusters, on the individual differences, and most of them happen to be there, but there's still a split on whether or not they're trait-like or state-like and behavioral. Whereas from general theories of trust, we see more of a natural split, although there's less research on looking at trust between individuals and systems, or using system level factors as part of the theory of trust. But about 77% of AI factors describe only one person's trust or a factor associated with the individual level. And then we only have 7% looking at team level trust, where at the same time, a lot of the research that we're focusing on and using is looking at how AI is interacting as a teammate, and who might have equal standing in some regards on the team. And so that means that when AI joins a team, trust becomes a group process. And so when we're thinking about the surgical team, where we have divergence in trust amongst members, we only we're only able to model really like each of their each the trust from each member individually. And when we're thinking about trust calibration, when we trust too much, we might think about how might this manifest. So in groups, monitoring being one of the main team processes that we see in expert teams. Trusting too much, we might stop checking, we might stop monitoring. Where trusting too little, we might not listen, we might not accept the work or even have perceptions of good intentions from others. And so we might reject or disuse whatever the tool is, or decrease interaction if it were a human. But the point is that in teams, these tendencies or that process occurs over time. And so this is a social negotiation, but we have no way of showing how this emerges. Like, how could we grow this from our understanding of how people are interaction? And so we're getting to a deeper question is not how does this person trust AI, but how does this group with divergent perspective, divergent cognition, divergent mental models, and experiences arrive at some sort of shared approach or arrive at some sort of decision with varying levels of influence from AI? So overall, these two traditions, the AI or like the core AI HCI factor tradition and our general tradition share a lot of common ground, but the focus on what engenders trust, what produces and maintains trust differs. While AI theories draw mostly from or seem to focus mostly in our view on individual semi-stable differences, we see much more, it's much more spread out when we're looking at general trust theories. And at the same time, there's also a unifying framework under the sources or the ideas of the fundamentals, where these ideas of competence, reliability, and predictability or integrity from ours are really the bedrock of trust. And one idea when one looks across the literature here is, trust may be, are we going to hit a developmental ceiling? Have we already hit a developmental ceiling? Mostly in terms of how we can study human AI teams, actual human AI teams, from the theoretical foundations that we have and the theoretical resources we have. So to go further, so like where do we go when we're trying to answer this question? Our approach in our research has taken this sort of what can we learn from, how can we take theory and try to uh, use it in an experimental sense, use it to develop good experiments, but then also how can we update that theory from what we get in our experiments? So I'm going to tell you about the major work that we're doing right now in terms of experimentation is we've created a virtual test bed. And this test bed is a military style situation, but it's mostly information retrieval, information compilation, and information integration between teams and interdependent task. So we're using just dyads, and individuals have to figure out which tasks are going to complete and split this up with the robot based on their understanding of the robot's capabilities. Now, for this, using existing theory, it pointed us to a lot of um, the most studied individual differences for trust being propensity to trust, agreeableness inside of the big five, um, and perfect automation schema, which is where we started. And what we found, we were looking at both this and contextual factors of, how well were the teams able to perform. And what we found was that as people were able to see or observe AI fail, these were like fundamentally changing the trust patterns. And I'm going to explain a little bit why. I'm trying to give you just an update before we get to this. But with our teams of two, where we had one individual and one AI, we had 141 of those teams go through multiple missions so that we could observe how well do personality and how well do personality and other individual differences, how well can we measure those? And then also how well do they correlate and predict trust related behaviors? And then from there, we tried to make a digital copy, a digital twin of this computational environment, of this virtual environment that the teams were operating in. And so in doing so, we also formalized the rules from theory that we could extract about how people and how agents interact and make decisions about tasks so that we can try to map or tune the data that we get from an ABM to our experimental data to hopefully feed back and forth to one another. Sorry, I forgot to tell you about our second study. We in our first study we were finding that it really didn't matter personality so much once people were able to observe failures in their task with AI early on. If it happened early on, these things sort of didn't matter at all. Whereas most theory that we read narratively would make us suggest that there's some sort of linear trajectory to trust. And so this was one of the first, also one of the first reasons where we're thinking like, under what conditions would we see that there's like certain scenarios where trust just cannot develop? And that was the question unearthed with our experimental data. In our second, we tested, we tried to remove this by making to where the observability of failures would be delayed throughout interaction. And we saw that this accumulated, so with 218 human robot teams, just allowing more time, more accumulated shared experience showed very different update patterns to where the first observation of failure from their AI or robot counterpart did not cause catastrophic failure in trust that could not be recovered. So I think one idea here is like our review told us or basically suggested that we should look into what might be team level factors. And so this is identifying where the gap was. And our initial experiments are really showing us where practical consequences might be associated with it. And the computational model that we're trying to build as a digital twin is really our attempt to figure out, okay, how does this work? What are the mechanisms? Um, what rules can we generate so that we can really start to create specific theories about what, or even test specific theories about how teams are operating when it comes to human AI trust and human AI interactions. So, when we're looking across the literature, like trust in teams, there's way too many factors associated with it for us to look at it at once. And for the experiments that we do have, you know, they they do they test a few factors at a time really well. But when we're thinking about what else could be involved, we're thinking about shared history. You can think about members' personalities, their emotions, their expertise, the overall team composition, including all of those at the same time, and even trying to manipulate those in an experimental setting becomes impossible. And so that's where simulation really comes in, where can we simulate realistic or realistic enough individuals and teams and units and provide rules that allow us to then explore systematically what might happen under various initial conditions. And this can complement experiments in a couple of ways. The predominant being that as we conduct experiments, we can compare whether or not from the model that we already have, are these expectations, are the data what we would expect or within what we would expect given the explanation we have governing this model. So it's not a replacement, and this is where the complement lies. And for our model, what we're doing is we're creating agents and we're trying to introduce all the elements necessary to explore realistic or increasingly realistic human behavior. And so this includes beliefs, And this beliefs can be observations, say, of performance. This could be perceptions of resources, perceptions of other individuals, even attitudes like trust. They also have desires, goals. Each agent, whether or not it's human or AI, they have these, though the way that we operationalize them might be different, but they have both social and practical goals. So, maintaining relationship ties, maintaining one's perception in others, following social norms, for example. And from these goals, they have intentions of behaviors, but they also have emotions. And this is one area where we felt like, where we still feel is the biggest question mark. But our agents have emotions because we're hoping to open up the field to how to theorize about the effect or the role of emotions, even at the micro level. And this has been one area where it's definitely the most challenging, but also the most interesting to try to do. And then finally, norms. So social rules, like reciprocity, fairness, these sort of perceptions that might modulate an individual's behavior. But given the differences or diversity in the team of some of the norms or strategies, behaviors, desires, might emerge as very different team level phenomena, especially when it comes to human AI interaction and trust and decision making with AI. Now our simulation is also modeled in like military intelligence, surveillance, ISR overall domain to match what we're doing in our experiment. And we basically have profiles for human and AI agents where we're able to specify specific skill gaps. So for the technical side, basically everything here is, modeled with beta distributions. But what this is really telling, what it really means is we're using a distribution to help modulate opinions and skills. So it's just a way of dynamically tracking how agents in our simulation perform and behave, and also how that performance and behavior is perceived by others. So we have these different profile types so that we could specify realistic strengths and weaknesses. So, AI have basically bands of capabilities that reflect current technology, being able to process things faster, being able to read or scan through photos faster. And so AI can exceed human performance in things like that and or like other like data heavy domains, but they fall short in sort of contextual judgment, interpersonal skills, being able to understand or well, given that we've done this before, a lot of the agentic technology has come out, not really be able to make as good decisions or plan quite as well. And so we wanted this so that we could create specializations. So we're looking at how various agents, in this case representing human agents, who have various strengths, can we model how they learn when to and when not to trust AI in various circumstances, particularly those where they're a good judge of the outcomes. So tasks where, say, the intelligent analyst shines, such as intelligence analysis or, getting through judgment or creating or like making good judgment based on contextual evidence. Whether or not that agent, when faced with, say, a task that is a logistical task, learning to correctly trust the agent that they are working with. And so this iterative throughout their mission, throughout their interaction, throughout their like interaction history, being able to observe when they are able to accomplish a task versus when their teammate might be better to accomplish a task, and learning this over time so that they can interact to optimize performance by knowing which of them should take the role to complete each task. And again, we were trying to mimic our experimental data collection. And so what we used was we first wanted to examine team composition at the most basic level, and that's just like number of humans and number of AI. This is to give us some clean comparisons, and also allow us to compare from the range of all AI teams to all human teams. And so this also highlights our idea of like how much does having an AI teammate impact team dynamics? How does it influence how teams operate or how teams attack a task? And for each of these, we're using a parameter sweep method. So we have the two agent types. The agent types all have they basically all observe their environment, see what tasks have been accomplished by whom, what tasks have been attempted and failed by whom, and also whether or not they have themselves attempted or failed a particular task. And so over time, the agents choose their task based on who's supposed to be best at it, or they might delegate a task if they know that one of their teammates is best at it. And so as we varied the composition, we were trying to explore which teams are able to optimize most, where might there be, how is trust developing from interactions between the agents and from just observations of the various team members' behaviors. And so we created a combination of basically all of the individual differences we've coded into our agents, which are like the big five: propensity to trust, big five propensity to trust, and perfect automation schema, which influenced the expectations that agents had, that the human agents had about the AI agents. And then we explored outcomes for the trust updating, the trust thresholds, and whether or not there was accurate expertise, accurate basically understanding of expertise throughout the team by the team members. So what we ended up with was we had 150 parameter combinations per each composition. And so the composition was just all the different ways you could combine human and AI agents in 2 and 3 agent teams. We're currently extending this to larger teams. And then we replicated each of those combinations 50 times for us to just explore what the differences were in team level outcomes from these combinations of agents who had systematically variable compositions themselves in terms of individual differences. Oh, I'm very sorry. I just explained, I thought I got ahead of myself. So I'm going to take a step back and say how we grounded the mechanisms inside of our agents was grounded in what we found to be shared across all the trust theories, was that we could generally find this grouping of ability, reliability, and alignment, in some cases being integrity and the others being predictability. And thinking about the surgeon example, this is just characterizing trust and where it might be measured from all the individual agents in a team. And so the surgeon might trust diagnostic accuracy, while others, or the surgeon himself, might question, the goal priority or or the AI's alignment and priorities. And those are different reflections or different observations of trust. Now, part of doing what we're doing here as well is we want to observe, as we replicate the same combinations multiple times, we want to observe whether or not the same trust level or same compositions lead to similar or wildly different outlines. So for an example, thinking about Agent A as someone who's detail-oriented, high in conscientiousness, but has a moderate trust, lower agreeableness, we might observe checking AI's work frequently, or flagging any team members' work for potential errors, whereas another agent with the same level of trust, but with a different personality profile, such as easygoing and having like high agreeableness, might barely trust AI's output, might barely trust anybody's output, might not surface that or say anything about it, and might not cause or bring too much attention to the failures in task. And then our use of emotions is that emotions might amplify reactions to trust and how trust changes. So, for example, if an AI makes a serious error, this is going to then be felt. It's it's going to have some sort of, because these are two agents working interdependently, is going to have some sort of bearing on the eventual outcome, on our goal-directed behavior. And we know that when we observe or we experience the something that makes the achievement of our goal less likely, there's an emotional reaction to that. We're trying to capture, simulate what those emotional reactions might be. And so whatever somebody's normal updating, if they were just observing, but it wasn't really, there wasn't this level of interdependence, in comparison to that, the trust drop, but also potentially trust increases might be sharper than just than what it would be in other circumstances. And this might then more drastically change behavior. So I'm trying to say this is like, this was again a callback to our attempt to see, are there situations, or is this a factor? Is emotion one of those factors that can help us understand why we can see this catastrophic drop in trust, like we've seen with our experimental data, where if the trust infraction happens early enough, it's just impossible to recover, basically. And so over time, these compile, but we're trying to figure out, where do they compile? Is it always getting to the same place? And um, so we're thinking that emotion might be one of these core features that helps us explain this curve that we're taking as an assumption. And so, high trust, we're thinking like, all right, as we're connecting behavior now to the integration of, beliefs, goals, and fractions, this monitoring behavior that we might see in other types of interaction behavior, we're seeing these nonlinear paths associated with them. And I think that this is where we're really struggling. It's like, how are all the different ways that we can observe, what are all the different ways that can observe team level behavior like monitoring, that show this sort of curvilinear effect that we can tie directly to trust or lack thereof, um, between human and AI, or even human and other humans, but our focus right now being human and AI. So what our model is showing us is that, when we have low levels of trust in general, there's going to be surveillance, but we also see monitoring, or increased levels of monitoring under high levels of trust, sometimes being due to an agent's conscientiousness, but other times potentially having to do with a collaborative, what might be a collaborative motivation. And so we're trying to figure out how, if this is the case, we can model and observe whether or not that occurs. But currently, the model does show that there are times where trust level is, where we're seeing this curvilinear relationship between monitoring and trust, and we're extending this now to other team level behaviors. Of course, hoping that this turns into some sort of mechanisms that we can use to add to the theory or the team level theory and trust. Now, the strength of our model is that we design these rules for individual agents and we create a context in which they're operating. And so what we bake in is our interpretation of all of the literature before this. So how personality shapes behavioral thresholds, how trust updates or minimally what factors go into the calculation or the experience of trust, the relationship between emotions and trust. And I think that the preliminary observations that we've made are pretty interesting, but we're also trying to tease apart what was determined from our code of like how we've created these rules versus what is something that might truly be emergent in other teams. And what we're surprised by, though, is these qualitatively different trust trajectories. And right now, they're all over the place. They're somewhat hard to make sense of. But one that we're particularly interested in is bifurcation of outcomes, where we just have bimodal distributions for the same compositions. And we're both like, we're all wondering now, like what this means, where we can have the same composition, but pretty consistently two distributions of outcomes, and how do our mechanisms that we've specified get us there? So we're not programming the team level patterns, but we're uh, wondering how much is programmed versus how much is something that is actually arising that we could, or emergent that we could observe in uh, in real teams or in experiments. So I hope you're seeing here that like what we're doing or what our process has been is understand what the theory says, understand what gaps are associated in the literature from theory, but also potentially in theory themselves. Using that to then, and there's the chicken and the egg problem, both instantiate a clear formal representation of what we mean and what we understand, or develop those where they're missing, like in our case, team level behaviors or team level factors contributing to trust, and then use that to both guide and be informed by experimentation, designing this like hopefully leveraging the fact that like any sort of computational approach can be a digital twin or a mirror to real life data collection. So overall, our team found a gap in AI trust theory. Um, our experimentation, our formal model guided that, and we were able to test new ideas to try to tune our data better, tune our computational data to experimental data. And then from experimentation back to theory, iteratively interacting with computation. So each is sort of revealing more of what we need to do in other areas as we get through it. So for each of us, for like our perspective right now, we have three like main directions. We're going to continue studying team trust directly, and trying to model team trust directly, mostly for calibration. Hopefully also to integrate distrust, which is something that came out in interviews after one of our experiments, where somebody said that they didn't trust, or multiple participants included that they didn't trust the AI, but there were times where they actively distrusted it for particular things. We're going to continue the simulations large scale exploration to continue to increase our team size, and also try to figure out which contextual factors we can isolate to reflect any sort of explanation or mechanism, some sort of path dependence to how the final trust emerges, and also the role of emotion. And finally, integrating AI, our LLMs, into our agent-based simulations to allow agents to have even more expansive and realistic interactions for us to increase the fidelity with not a lot of not a huge lift. And so with that, we'll finish with, AI trust theory. We have a huge, or what we would say is a noticeable problem when we're thinking about a lot of the work that we're focusing on with human AI teams not being able to explain the team factor in how human AI trust plays out. Cycling between theory, computation, and experimentation, even within one lab to like help reveal what those dynamics and iterate on, as far more informative than any one process on their own. And noticing that the tools that we're building, be it a virtual test bed or computational model, none of them being an answer in and of themselves. It's been interesting to see the theories that they help us generate, or the hypotheses that they help us generate as well, and the critical theoretical lens that it forces us to have. And with that, I will stop and give us plenty of time to discuss and ask the detail-oriented questions that I'm sure are there about any aspect of this work.
Thank you so much, Dr. Outland, for the wonderful presentation. We'll now open it up for questions. The audience can unmute to ask questions or post the questions in the chat or just a Q&A sections. And for the sake of recording, I'll read your questions as they come in and post them to our speakers. Yeah, we have one question coming up during your talk. Have you tested if the humans are willing to work with AI to make it better, such as providing inputs to improve the model's performance? Does the trust increase when the AI shows improvements with their inputs?
Oh, so we actually don't have, we did not look at whether or not they were trying to improve the model. Part of this is because of the limitation for our experimentation. Our humans, despite what they said, could not meaningfully change the behavior um, of their AI counterpart. Um, so more than just like influence it to do task, right? So they could ask that it goes and performs a task, but um, things that would be viewed as like preferences or anything like that, not so much.
Uh, the audience asked, is there any kind of like benefits or risk of doing the computational model first and then the experiment, or do you do both directions and refine accordingly?
Well, it was happening basically after we'd done our systematic review of theories, um, they kind of happened in parallel. So we had an idea of like what do we want our context to be, and our meetings then became mostly like, okay, so once we figured out the military context, what's the actual task context, and we settled on missions, and so like, okay, so what's the structure of a mission? And at all times, we were making decisions that we knew we could represent in both places. Like, yes, we can build this into the test bed, and we can reasonably and easily represent this inside of a computational simulation um, without, like, within the same or similar time frames.
Really, Catherine Blake have a question. Can you put in chat or uh, the way that we can unmute you?
Oh, reach out or reach me?
I mean, uh, I don't know if Luis can unmute Catherine, or Catherine, can you put it in a chat so we
Let's see.
can read the question?
Let me find her. Yep. Fabulous. Thank you. Can you hear me okay?
Yes.
Fabulous. Thank you. Thank you for a fabulous presentation. So I guess I have so many questions. So I think I'll start with, so I'm in a college of medicine, and in that environment, there's sort of a command and control structure. So you sort of mentioned sort of a surgery as one of your case studies. And there's only so many sort of tasks that can be handed off. And so I guess I was just curious about how you might include that in your simulation, sort of, this environment where sort of people's roles and responsibilities are fairly well defined, whereas it sounds like sort of the information task was sort of more fluid in who could do what task.
Yeah, absolutely. So, one focus for our computational model, we were trying to see how it develops naturally. Like if decisions had to be made and, skills had to be learned instead of having a social reference like a certain like badge or role where it was, determined top down. We're really trying to see like how emergent, under what rules would, like trust emerge and fluctuate, uh, basically starting from a nebulous starting point. But we could, and yes, we have thought about including or specifying certain things that like the AI or that the human could do. Um, but what we've implemented thus far has actually, and we've put this into one experiment, is just making it to where by the context it limits which one would have to do it. So, for example, but I haven't thought about this in like a completely like knowledge-based task. But in ours, as they had to navigate this room, this compound that they were looking for information, like one part was blocked off to where like only the AI teammate could go in and search for information there.
Mm.
So we have like one version of our simulation that handles it that way, where it's still there's very clear boundaries based on the context as to which one could or should do what, um, but not specified in terms of roles.
Mm. Excellent. Thank you.
And this can also help us like unmute James. I believe he have had a kind of follow-up questions.
Go ahead, James. Hi, can you hear me?
Yes.
Hi, Neil. Good to see you again. Thanks so much for coming to present. And I just want to share, like, I'm obviously a massive fan of the whole paradigm you're proposing, if you will, the kind of the blending of all the models, of course. So one question I had is just, and I don't know if this is a question or comment, so take it for what it is, but I was thinking like, it struck me that when you were doing your review and kind of thinking about like the construct and the concept of team level trust and such that it was almost begging the question of like, to what degree do we need to have, or is there a useful assumption for us to have like this consensus within the team that we trust this AI? Because it sort of strikes me that depending on the nature of, let's say, that AI agent itself or what it's being asked to do or who's needing the information it's providing, that the consensus or that we trust this thing may or may not matter, right? And so I was wondering, like, in the context of your either review or your framework, and maybe this even goes all the way into like the nitty-gritty of your model and such, like, um, can it be the case that it's still we're still really just the focus is still on how individuals themselves react to like what the AI is doing, because at the end of the day, it's the individual that needs to make a decision. And it may be the case that we all have to pursue our own goals and this, that, and the other, but this idea that we all have to kind of, or that not that we all have to, but that what's the significance, I suppose, right, of having like the consensual team trust in the AI as opposed to still kind of monitoring at this individual level, as you were kind of highlighting it, that where a lot of these trust models seem to exist now.
Yeah, I think that's a really good question, and we're really like trying to observe like, hey, it's not, does it have to be like completely, it doesn't have to be a complete consensus, but also what might the compilational breakdown look like, right? So if we understand, say, like how who you trust and how who the people that you trust others. So like looking at like the network and like transitive properties, um, how that influences even like the individual levels of trust, right? So we're going through like from a competence or like um, from like the cognitive perspective of trust, we're like looking through like ability, benevolence, integrity, like to determine trustworthiness. Um, and I didn't highlight that here, but like something that comes up for us is like, well, there's a social component to decision making, and that's what would be at the team level. And it can be both, like observational, like I've seen this other person trust AI, and I trust, or like I've seen this person trust like our AI teammate, and I trust the AI teammate. So that might be a convergence process where we all start to, if the team is, for example, the team's cohesive or has the foundations for those relationships, it might be a mechanism for convergence. But the opposite will be true, could be true as well, where if I have a poor relationship with someone who maybe is more trusting or has greater affiliation with the teammate, that their reaction might make me rejected more. And so there's definitely going to be some things that we could observe, even just at like the team level, but these are, from our perspective, inherently going to interact with the individual level processes. So as we're thinking about this trust influencing over time, or the iterative nature of it, even in individuals, um, given that a lot of this AI is like being introduced into the realm of work, we think that we need to have that to help us understand what are the additional factors we're not currently accounting for in the individual level equation. Sorry, that was a little long-winded.
No, I don't. Oh, I'm sorry. Yeah. I got, yeah, I agree. It's like a really difficult, interesting and difficult question. I mean, my part of maybe what was also stimulating that question was your observation and some of your stems. You said that you're getting these sort of bimodal, one time they end up on the high level, one time they ended up on the low level. And I was wondering, we wonder maybe in the context of, yeah, it could just be some model artifact, but it might also be this thing, as you're saying, you're starting to piece apart that when you end up in one of these, attractors versus the other depends on if it's, everybody's agreeing or it's just a couple people agreeing with this thing. And so when it looks like trust is fracturing, it's not really like consensually the whole team has disagreed that we don't need to trust the AI anymore, but it's like a couple people are deciding to kind of pair up with the AI and trust it, and others are not. And so then that is like a more this convergence thing, but it's striking me that like this distinction between measuring trust or kind of conceptualizing trust as this agreement that we all trust the thing versus still kind of sticking to these patterns that you're describing of like this network of trust sort of patterns um, might end up, perhaps revealing some of those, why some of those paths are playing out the way they do. But anyways, I'll turn it over to somebody else. Thanks, Neal.
Yeah, absolutely.
Anybody have a question? You can put it in chat or just raise your hand. We can unmute you. Okay. Okay. Yeah. Okay. Thank you. Thank you everyone for coming once again to our wonderful speakers, Dr. Neal Outland as well. Please check our website, which we I've just put in the chat to see more events. And we have also speakers lined up for our speaker series. Our next speaker is Connie Sable from College of Information, University of Maryland on April 17th. Thank you for coming.